In this video, we are going to talk about overlay management protocol. Overlay management protocol is very important for the SD-WAN fabric to establish the control plane of the vEdge routers. OMP runs over the overlay network between vEdge routers and vSmart controllers. It uses TCP and enabled by default. OMP allows vEdge routers to securely exchange routing policies with vSmart controllers. OMP allows vEdge routers to securely communicate over IPSec tunnels over the underlay network. OMP operates by establishing peering between vEdge routers and vSmart controllers. vEdge routers receive the list of the vSmart controllers from the vBond. Once the vEdge routers receive the list of the vSmart controllers, it starts by establishing OMP peering with the vSmart controllers. vEdge routers don't establish OMP peering with each other. Routing information is sent from each vEdge router to its associated vSmart controllers. Then vSmart controllers will reflect the received routing information to the other connected vEdge routers. If we have a multiple of vSmart controllers, vEdge routers are not required to peer with all vSmart controllers on the SD-WAN fabric. We have different interface types for the SD-WAN fabric. Transport side, which is the vEdge interface connected to the underlay transport network. On the topology, we have Giga Ethernet 0/0. It represents the transport interface, named with VPN 0 interface. This interface will handle all data traffic between vEdge routers, encrypted via IPSec tunnels. Another interface type, which is service side. Service side is the vEdge interface connected to the customer branch side. In the topology, we have vEdge router is connected to another branch CE router via interface Giga Ethernet 0/1. This interface is represented by VPN interface, and the VPN interface has a number with range from 1 to 511. Traffic is forwarded as received. From the vEdge router, send traffic over the IPSec tunnel to another vEdge router, then the traffic is forwarded to the service interface. The service interface handles data traffic between customer routers and vEdge router in each site. Another interface type, which is the management side. vEdge interface connected to the management network. In the topology, Ethernet 0 represents the management interface. The management interface is known as VPN 512. This management interface handles the OMP traffic between vEdge routers and vSmart controllers, and vManage can manage all SD-WAN devices over the management network. The management network is entirely separated from the control or service networks. Another important terminology is transport locators or TLOCs. TLOC identifies SD-WAN vEdge's transport locations on the overlay network. TLOC is formed by the following: system IP address or the logical IP address, its loopback interface, and is configured locally on each vEdge router. The color, which identifies the WAN circuit type on which the vEdge is connected on the transport network, and it has two types of colors: private color like MPLS or Metro Ethernet, public color like public internet, and finally encapsulation type. So TLOC consists of system IP address, color, and encapsulation type. WAN circuits with different colors can be configured to not communicate to each other. If we have a routing prefix between a CE router and vEdge router in a specific or a certain branch site, this routing prefix will be advertised to the vSmart controllers with TLOC in TLOC route via OMP protocol. Then the vSmart controllers will be able to reflect the received TLOC routes to other vEdge routers to announce the existence of the vEdge TLOC and the prefixes received from this vEdge. IPSec tunnels must be established between vEdge routers over the transport network. So vEdge routers can exchange data traffic over them. Prior exchanging data traffic and establishing IPSec tunnels between vEdge routers, control plane must be established via vSmart controller. If we have an issue on the control plane, IPSec tunnels will not be able to be established. Each vEdge router advertises its encryption key to vSmart, then vSmart reflects the key to other attached vEdges. That will be done via the OMP protocol. We have 3 vEdge routers connected to one vSmart controller. Each vEdge router has its system IP 1.1.1.1, 2.2.2.2, 3.3.3.3, and each one has a VPN 0 represented with the green color. So each vEdge router will have its system IP and the color to represent its TLOC, and it will start to establish the OMP protocol with its vSmart controller over VPN 512 or the management interface, and TLOC routes will be advertised between each vEdge router and vSmart, which include the prefixes received from the customer sites over the service interface, and each prefix will be associated with the TLOC of each vEdge router to the vSmart controller. Then the vSmart controller will reflect the received TLOC routes to other vEdge routers. After that, the IPSec tunnel will be established between each vEdge router. After generating the encryption key of each vEdge router, then to be sent to the vSmart controller, then the vSmart controller will reflect the encryption keys to the vEdge routers. So the IPSec tunnel will be established over VPN 0 or the transport network, so the traffic can be securely exchanged. Thank you for viewing this video. I hope it can add a good value for you.